Section 6.7, synthetic division. To divide a polynomial by a binomial of the type x minus a, we can streamline the usual procedure to develop a process called synthetic division. When we're using synthetic division and we're missing a power, we need to be sure to include a placeholder. We are dividing a polynomial by a binomial. It is of the form x minus a, so we can use synthetic division. But in this example, we're working with a third degree polynomial. We have a x to the third and x to the second, but we're missing our x to the first power. There is no x or x to the first power. So when we do our synthetic division, it's important that we note missing powers and put placeholders for it. So our procedure for synthetic division is to put the value of a in the corner. And if you look at this, our a is really, it may appear to be a minus 3. It's the opposite of what it looks. It's matching our form, and some think of it as the opposite of what it looks like, and that's all right. Next, then, we put the coefficients of our powers in decreasing order adjacent to our a value. So we have a 4, we have a 2, and as I already pointed out, we're missing our x to the first power, so we'll put a 0 for our linear term, and then we have our constant term. For synthetic division, we then bring down our leading coefficient. We multiply it by a, 4 times 3 is 12, and we place it underneath the next coefficient. We then add those two numbers together. 12 and 2 make 14. We then repeat our multiplication, taking that result times 3. 3 times 4 is 12. Carry the 1. 3 times 1 is 3, plus the 1 more makes 42. Adding that to 0 gives us 42. Then we go back and we multiply again. 3 times 42, well, we would have a 3 times 2 is 6. 3 times 4 is 12 for 126. We add it to the 5 for 131. These are the coefficients of what we call the depressed equation. It is 1 lower degree than what we started out with. We started out with an x to the third term, or a third degree polynomial. We will have a second degree polynomial, and 4 will be the coefficient or the leading coefficient of x to the second power, 1 lower power than we had. The next term is the coefficient of the next lowest power, and since we're at x, our next value is our constant term. This last value here is our remainder. That's telling us that x minus 3 did not go in evenly into this polynomial, so it's not a factor. And to write our quotient or answer to the division problem completely, the answer is 4x squared plus 14x plus 42 plus 131 over x minus 3, our remainder. This then is synthetic division and a shorthand version of long division normally used for polynomial division.